If your floor creaks louder than your regrets, it's time to fix it before gravity does it for you. Before we get started, check out the link in the description to download our ebook. Check out our merch, brand new Christmas stock. Use the discount code YouTube, link in the description. Now let's get back to the video. Let's start with why this matters, because I know you're tired and possibly in shock about the state of things. But listen, weak floors and collapsing shelters don't care about your feelings. They care about physics. And physics, my friend, is undefeated. Weak floors happen for several reasons. Maybe your shelter is built on compromised structure. Maybe water damage has rotted the support beams. Maybe someone before you thought it was a good idea to stack everything they owned in one corner, and now half the floor is actively saying goodbye to the other half. Or maybe, and this is popular post-apocalypse, you've got sagging ceilings from an abandoned building that's been quietly failing for years. The danger here is twofold. First, the obvious one. You fall through, you break something, and there's no ER anymore. That's bad. Second, and sneakier, a compromised floor doesn't fail all at once. It shifts, it warps. It slowly redistributes stress to other parts of your structure until the whole shelter becomes unstable. And then you're not just fixing a floor, you're rebuilding everything that was holding it up. So we're going to stop that before it happens. Here's the thing about structures that non-engineers find confusing. Buildings don't defy gravity. They manage it. They do this by creating paths for weight to travel down to the ground. Think of your shelter like a line of people, passing buckets of water in a fire line. The water starts at the top. That's your weight, your supplies, your body, and each person passes it down. When someone in that line gets weak, the bucket bounces around. People on either side of the weak link have to work harder. Eventually, somebody drops it. In buildings, we call those people load paths. They're the support beams, the joists, the walls that carry weight down to the foundation. When you've got scrap materials and rope, you're not changing that fundamental truth. You're reinforcing weak links in the bucket brigade. You're giving the failing members backup. You're making sure the weight doesn't all punch through one spot. Here's how it works in practice, and I want you to picture this, because we're not using visuals today. Imagine a floor that's sagging in the middle. The middle of the floor has become the weak link. Weight pushes down there. There's nothing strong enough to push back, and so the floor drops. Now, if you add support directly under that spot, a wooden post, some debris stacked in a triangle, whatever, you've created a new path for that weight to travel down. The floor now has a choice: press down on the original structure or press down on your new support. It'll use both. That's physics working in your favor. But here's where it gets interesting. You can be smarter about it. You don't just add one support, you add multiple supports arranged in a way that distributes the load. You use rope to tie things together so that when one piece shifts, the others hold it steady. You layer materials so that if one fails, there's always something behind it. That's the job. Let me break down the actual techniques you'll use with whatever's available. These are simple enough that you won't need a structural engineer's degree, though God knows where those people are now. First, cross-bracing. This is your workhorse. Here's the principle. A single vertical support is strong, but it's lonely. If it gets hit from the side, or if the surface under it shifts, it fails. But two supports arranged diagonally to each other create a triangle. Triangles don't buckle sideways. Triangles don't twist. Triangles are basically the pit bull of geometry. They hold. So whenever you're reinforcing something, if you can create triangular shapes with your scrap wood and rope, do it. Diagonal bracing resists lateral stress and prevents shifting. Second, rope tensioning. Rope doesn't work the same as wood. It only works under tension. It pulls things together. But that's powerful. Use rope to bundle reinforcements, to tie supports to load-bearing walls, to connect separate stabilization points into one system. Rope's also useful because when the floor flexes slightly, and it will, rope can flex with it without snapping. It absorbs movement. Third, layering scrap planks. If you don't have solid beams, stack them. Put one plank on top of another, nail or lash them together, and suddenly you've got something stronger than either plank alone. This isn't professional carpentry. This is practical engineering. The stress spreads across multiple pieces instead of concentrating on one. If one plank has a weak spot, others share the load. Fourth, wedges and shims. These are your tactical players. A wedge under a sagging beam forces the beam back up and redistributes the weight. A wedge under a shaky support column locks it in place. You can make wedges from scrap wood by splitting a branch at an angle or stacking debris to create a slope. Wedges are simple, they're effective, and they work with gravity instead of against it. All right, let's walk through some scenarios so you understand the logic. Scenario 1. Your floor dips in the middle. What you're seeing is the joists, the beams running underneath, sagging under weight. Here's what you do. You identify where the dip is worst. You create a temporary support system. Take your scrap wood and arrange it in an inverted V beneath the sagging area. This forms a triangle. Lash it with rope at the apex. Wedge the base points into existing structural elements or dig them into the ground for stability. Now that sagging joist has a handhold, the weight doesn't all press down on the weakened wood anymore. It presses down on your temporary support system. Scenario 2. You've got a wall that's leaning. Maybe an exterior wall has lost its bracing. You go outside, you take scrap lumber and create diagonal braces from that wall down to the ground or to another stable structure. These braces should make an angle, ideally 30 to 45 degrees. Lash them tight with rope. You've just told that wall, stop moving. The braces are taking on the lateral stress that was causing the lean. Scenario 3. You've got a ceiling that's sagging, and there's nothing below it but open space and bad decisions. You install vertical posts underneath to support it. But here's where technique matters. Those posts need footings. You can't just set a wooden post on dirt and expect it to hold. You pile debris, flat stones, scrap metal, whatever, to create a base that distributes the post's load across a wider area. Then, you secure the top of the post to the sagging ceiling member with rope or whatever fastening you have. The post is now sharing the ceiling's weight with the original structure. In all three scenarios, the logic is the same. Identify the weak point, create an alternative load path, secure it in place, and distribute the stress across multiple points. That's reinforcement. Before we move on, let me tell you what will absolutely get you killed, because people try this stuff. Do not use wet cardboard as a beam. I know it seems solid when it's been sitting in a corner. It isn't. Water has compromised the fiber structure. It will compress and fail under minimal load. Your shelter will drop. Use it for insulation if you want. Use it for walls. Do not use it for structural support. Do not stack buckets or plastic containers as vertical supports. Yes, they're rigid. No, they cannot hold weight. The plastic will creep and deform under stress, especially in temperature fluctuations. Your whole system will slowly collapse as the buckets compress. You'll wake up partially embedded in your floor. Avoid this. Do not use a single rope to support something that needs multiple supports. Rope is strong in tension, but it's only as strong as its weakest point. If you've got multiple load paths, you need multiple ropes or redundancy. One rope fails, your entire system fails. Do not assume that piling debris creates stable support. A pile of random junk will shift and settle. It will compress unevenly. It will fail catastrophically at 2 in the morning when you're directly above it. Before you use debris as a structural element, organize it, compact it, lash it together if possible. Make it intentional. Do not ignore water. Wet wood is weak wood. It rots, it swells and shrinks. A wooden support that's damp will fail faster than one that's dry. If your reinforcements are getting wet, your shelter situation is larger than a weak floor. Address the water problem first. Let me summarize the actual process, because we've covered a lot and your brain is probably running on fumes. Step 1. Assess. Look at your structure. Where is it failing? Where's the sag? Where's the lean? Where's the crack that's spreading? Be honest about it. Denial is comfortable, but expensive. Step 2. Identify load paths. Where is weight going? Where is it being resisted? Draw a mental line from the heaviest point down to the ground and find where that line might break. Step 3. Create reinforcement. Use your scrap wood to create triangular bracing where possible. Create additional vertical supports where needed. Install wedges to adjust angles and distribute weight. Think about how forces flow. Think about redundancy. Step 4. Secure everything with rope. Lash your supports to existing structure. Tie them to each other. Make it one integrated system instead of individual pieces leaning against each other. Step 5. Test carefully. Once you think you're done, add weight gradually. Small movements are normal. Sudden shifts are bad. If something's not holding, you'll know quickly. The goal isn't perfection. The goal is stability. The goal is to add enough secondary support that if one element fails, others are already carrying the load. Combine rope, boards, and leverage. Use your environment. Use gravity's own weight against it. Create mechanical advantage through geometry and distribution. Here's the thing about survival. It's not about comfort. It's not about having what you had before. Survival is about convincing gravity to wait another day. It's about making structures hold that should, by all rights, be falling down. It's about using whatever's left to build something that won't quit on you. Your shelter is the difference between sleeping and not sleeping, between staying dry and not staying dry, between surviving the next week and becoming a cautionary tale someone else learns from. So, check your floors, check your walls, check your supports, and if something's wrong, fix it now. Don't wait for it to fail, because once it fails, gravity doesn't negotiate. Thanks for watching. If you found this useful, subscribe. If you found this depressing, well, yeah, that's the world now. Stay structurally sound, and we'll see you next time on Apocalypse Infrastructure.